Hello, welcome back for part 2 of this tutorial on creating a third person shooter. If you've just watched part 1, well done, you've completed it. And what we did was we created the movement and even a jump for our player by simply going to Unity scripting API and doing a bit of a cheat and copy and pasting. Let's find where we were, there it is. And we copied and pasted this, crack this straight into our player script and found that it worked straight away. And what we're going to do in this video, if we've got the time, is to hopefully edit the script to how we want, simplify it, then ensure, obviously make sure it works still. And then what we're going to do is go on to our camera view and making sure we can get our camera views of our looking on left, right, up and down, and all of that kind of stuff. So, right, so this is what we did. Let's just make sure this works before we go any further. There we go, moving around, lovely, lovely. And even jumping and jump and stuff like that works and everything like that as well. Fantastic. Cool, so we're going to simplify this script. Make it a little bit easier for you to understand because it might still be a lot to kind of take in. Even though we've got a pseudocode, what we can do. So character controller is named character controller. We can just name this controller, just make it more simple, underscore controller. And what I'm going to do is make this a private variable, simply because nothing else needs to control our controller, and everything will be within this script. So it may as well just be private, just like all of these as well. So I'm going to take all of these publics and we're going to make them private. There we go. Oh, spell private right then, might be good. Cool. And private. Cool. And one other thing I'm going to do, make that float, is also make sure these are a serialized field. This means this enables them to be edited within Unity in the inspector. So let's do that. Serialized field, please. There we go. Cool. And I'm just going to add underscores just to know that these are my variables that I have created. Good, lovely, good start. Victor3.0, that's for world space. Come back to that, I'll leave that for now. That is just our underscore controller, there it is. And we'll change this to underscore controller as well. Move direction, and that's okay. Jump speed, jump speed, gravity, they're okay. Jump speed, I'm going to change that to jump height because it's not the speed of our jump, it's the height of it. Update is controller is grounded. Okay, this is a really long way of going around things. We don't need this here. We don't need that. So what we're going to do is we can just type in input, or not even that. We can type in float. So we create a variable within this method. So horizontal, which then equals input dot get axis, which is then going to be horizontal. We've done this before in previous tutorials, so it shouldn't come as a shock that we're doing exactly the same thing again. Just ease of practice. If you can do this for all of your games that you're making characters for, you're laughing really, because it's just, we're breaking this down to the easiest, simplest script possible. That's fine, that's fine. We also need to say, if we simplify this, so what this is saying here is that we've got a private vector 3, which is obviously our character. The move direction equals 0 around our world space. So technically world space is not affecting it, because you can have sort of glitches with rotation and stuff like that, and horrible things when you start adding more things into your game, into your level. So that's why they've done this. But I'm going to simplify this to a private vector 3 and just call this underscore direction. And then here I'm going to add underscore direction equals a new vector 3. If I can spell vector 3. New vector 3, which will then be our x will be our horizontal. Y, we're not going anywhere with that at the moment because it's our jump, and then let's be our vertical for our up and down on our z axes. Lovely, that should control that. Then we've got this, it's now saying this is wrong, which is because we obviously change direction. There we go. Let's change this as well. So we're just simplifying this, making this a lot easier. It's not jump speed, we changed it to jump height. There we go. That's looking good. Here we're going to say underscore direction dot y is then minus to our gravity. Then, so really I'm breaking down the names of everything because it doesn't need all of this, and that should be it. If there's anything that may catch me out, I never know. That's looking pretty good. I'm quite happy with that. So if break this down, so we have our speed, we have our jump height, and we have our gravity. Our direction, which is going to control all of our movement, is controlled by vector 3, and then that is implemented into our controller, which is get component character controller. So everything, all the movement and direction is just a variable essentially for our character controller. Then if our controller is grounded, so if we're on the ground, if we're on the floor, we're colliding with something, this still will actually works if we are grounded, so we recalculate. So our horizontal equals our left and right movement, and our vertical means our backwards and forwards movement. We're then saying we're changing the direction with a new vector 3, horizontal, nothing on the y because it's only a jump, which we call up later, and for our vertical movement, and all of that movement is controlled by our speed variable. So we're saying direction is times equals by our speed. We're then saying if we press a button, so we're saying if we use the input axis of jump, our direction on the y is then equal to our jump height, which is 8. But then once we have hit this, we will be hit by minus equals to our gravity in time.delta time. So instead of like almost like jumping and it looked like it glitching out because it's forcing us down, time.delta time, so real time, will create the sense of gravity within our game, and then our whole entire controller movement and direction is times also by time.delta time. So if we save that, go back into there, click play, hopefully that's reading that. That will go into there, press play. There we go, everything's working. Lovely, and I've jumped off the edge, fantastic, in celebration. Okay, so that is all working absolutely dandy. So what we're going to do now is have a look at our cameras. I don't know why I'm all the way up there. I'm going to put myself down a little bit. That's cool. And first things first is just like with our first person, where we positioned the camera in almost like the head of our capsule. We're going to position our main camera as a parent of player, and then I'm probably going to zero out the camera and then I'm going to pull backwards. There you go. You can see our controller move up, move left. So you're kind of creating that kind of Resident Evil-y. It's not. I might just make the controller play a little bit longer. Actually, just to position scale. So he looks a bit taller. We then go back to our main camera, move alongside like that. Something like that. Yeah, cool. So let's just make sure the camera is actually attached. We should be able to see this from our scene, and as we can see, it is. So what ideally we want to do now is create don't forget to save, create a movement on either the y-axis or the x-axis for our up, down, look all around kind of stuff like that. So what we're going to do is click on our camera, and if we do rotation on our y, we can see that it almost, within our game scene, it looks like we're looking from left to right. So we know that rotation on the y is key to creating looking around left and right. And then up and down, if we move our rotation there, you can see that's changing as well. So for looking left and right, it's Y, and looking for up and down, it is X. Cool. So what I'm going to quickly do is just zero those off, and let's go back to our script and see what we can do with this. Okay, so I'm going to get rid of this pseudocode, just because it's bunching up stuff here. Cool. So what I'm going to do is I'm going to create a brand new method, and I'm going to call this void movement, and do some curly brackets for it. And what I'm going to do here is copy everything within update, so or Command X, which is what do you call it, cut, and I'm going to paste my I've done too many. I'm just going to go back, take that, Command X, there we go, and then Command V. So all of my movement is now in a void, its own void, in its own method, and that will still work. That's still working as the same as update, so we don't have to worry about that. That's there. That's all good. Okay, so within update, we need to think about those rotations on the X and on the Y. So what we're going to do first is exactly what we've just done essentially here for our input get axes. So I think we've done this for first-person controllers, but just going to show you again. If we go edit, go down to project settings, go to input manager, axes, we can see we've got a mouse X and we've got a mouse Y. Okay, so Unity has already got the implementation for mouse movement, which is awesome. So we're going to utilize that and put that into for looking around within our camera. So if we go back to our script, and just like we've done here with our horizontal and our vertical, what we're going to do within update for our camera movement is that we can do float mouse X equals input dot get axis, and then we can call up mouse X. There we go. And then the same again for Y, input dot get axis, mouse Y. Lovely, there it is. So Unity knows we want to use those, and we can keep those there, and we can call up mouse X and mouse Y when we like, because they're just local variables within our update method. So we need to do two things. Enable, let's just do a bit of sudo looking left and right, and looking up and down. Okay, let's do left and right first. I think that'll be easy, tad bit easier. So we need to use something called Euler angles. So we use Euler angles and quaternion simply because rotation can almost get fixed or glitch out and create and doesn't create good movement within world space. So that's why we use Euler angles, or Euler angles, whatever they're called, and quaternions for this. So what we're going to do for looking left and right, we can say new vector 3 because it's a new position, and I'm going to call this rotation on the Y. And excuse the pun, but why I'm going to do that is if we go back here to look left and right, if I go back to my main camera to look left and right, if I move the rotation on the Y, that's creating my look. So I know that's my reference. So that's why I've got that there. Cool. So rotation Y is going to equal Y transform dot local Euler angles, and then rotation Y dot Y, because we're talking about just the Y axis, is plus and equal to mouse X. So whenever I move mouse X, that's when my rotation is going to move. Here comes the confusing transform bit. So it's transform dot rotation, but we are going to say equal to a quaternion and dot angle axis, and then rotation Y. Oh, didn't want to do that. That's helpful. Rotation Y dot Y, because we just want to rotate on that, comma vector 3 dot up. Semicolon. Okay. Let's save that, and let's see if Unity is looking good. Just press play, and there we go. We are looking left and right, and as you can see in the scene view, my camera is moving around quite well on that axis because my controller's moving. So if we click on the player and then click back onto here, you can see that the player is moving with the camera while I'm looking around. Cool, awesome. I'm glad that works. Okay. So we need to look at looking up and down. So this will be a bit different. And before, I kind of created, I think within, when we created a first person controller, we did looking up and down, but then we did something weird with the parent, and I think that was just a kind of a quick fix, I'm not gonna lie, to kind of get around an initial problems I had with creating a first person controller from scratch. But we've simplified it now, and hopefully we can get this working. So first of all, we need to have control of our camera before we go into looking up and down. So if we create a brand new variable, and what should we call it? Oh, I need to call it up first. So what I'm going to do is let's go private, call up camera, there it is, and we're just going to call this main camera. Cool. And then in start, we're going to say, because every time we want to start our game, we want that camera to be boom, locked up, called up straight away. We don't want it to be doing anything weird. So what we're going to do is, in our start, we can write, we called it main camera, underscore main camera is equal to camera dot main. Cool. So what that should technically do, if I go to here, if it all saves properly, loads up. If I click on main camera, it should be, there we go. Cool. I'm not sure if it's always tagged as main camera, but it now is. There we go. So that should help us there. So we've got a variable of main camera. It starts right at the start of our game, so it knows what it's doing and where it is going. We are then going to, so we are going to write vector3, like before we did rotation Y. This time we're going to do rotation X, because obviously we're looking up and down on the X. Let me spell rotation correctly. Rotation X, which is going to equal underscore our main camera, and dot game object, can't forget that, then dot transform dot local auto angles. Cool. We then can say rotation X dot X, because obviously we're now looking on our x-axis, is going to be minus equals, not plus, because that will just invert our controls if we do plus. Mouse, mouse Y, obviously. And then to finish this off, we can say underscore main camera to our game object dot transform dot rotation is equal to quaternion angles, angle axis again, and then rotation X, just like before. Rotation X dot X, obviously not Y, comma vector 3. Why does it always do that? Vector 3 dot right. Cool. Okay, let's test our scene and see what that does. Clear that. Let's play this. Okay, something's gone a bit. Our camera is kind of restricted movement. Okay, our camera shouldn't be moving that much. Okay, let's just click on the camera and see what it's doing. Okay, so what our camera's moving. If you look in our scene view, our camera's moving way too much as I move the mouse around. So it's got to be to do something with the rotation. If it's vector rotation Y equals transform dot local Euler angles. Okay, I believe it is. It should be, if it's local Euler angles, it should be local rotation. Cool, local rotation, lovely. And local rotation, lovely. Cool, let's save that, check this out. Come on, Unity, and see if this has fixed our problem. Oh yeah, that's a lot better. fantastic. I might need to move the camera in a different place, but we are fixed where we want to be. Awesome. There you go. So that's what's done it. The I accidentally didn't put local rotation after the transform. It said transform dot rotation, but obviously we want to keep it in our local space, not our world space, because it's just player movement, not movement around the world. And that's fixed it. Cool, lovely. Thank you very much. See you soon for part 3.